One of the last things that we're going to look at in this section is Descartes' rule of signs. So the rule says, let f of x equal a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 plus a sub 2 times x squared plus a sub 1 times x plus a sub 0 be a polynomial with real coefficients. We know, remember, this just means a polynomial in standard form. So we have a standard form polynomial. It has real coefficients, and a sub 0 is not equal to 0. Our constant term is not equal to 0. As long as that is the case, then we can say that the number of positive real zeros of our function is either equal to the number of variations in sign of our function or less than that by an even integer. We can also say that the number of negative real zeros of the function is either equal to the number of variations in sign of f of negative x or less than that number by an even integer. So we just have to look at how many variations in sign do we have. Variations in sign, how many times do we change from positive to negative or negative to positive? So we're going to look at how we use Descartes' rule of signs to determine the possible number of positive and negative zeros for a couple of functions here. First function we're going to look at is f of x equals 4x squared minus 8x plus 3. So if we look at this function, f of x equals 4x squared minus 8x plus 3. How many variations in sign do we have? Well, our first term is positive. Our next term is negative, so that's one variation. And then we go from a negative to a positive, so that's another variation. So we have two variations in sign. So we can say that our function, f of x, has either 2 or less than 2 by an even number, meaning, subtract 2 from it. So 2 minus 2 would be 0. So we have either 2 or 0 positive real zeros. We can also use Descartes' rule of sign to see how many negative real zeros we have. But to find how many negative real zeros we have, we need to look at f of negative x. So if we take our function and we replace all of our x's with negative x's, and then our function is going to become 4 times negative x squared, means negative x times negative x. A negative times a negative is a positive. X times x is x squared. We multiply that by 4, so we have 4x squared. Negative 8 times negative x would be positive 8x, and then plus 3. So how many variations in sign do we have here? We have a positive, and then a positive, and then another positive. So we have 0 variations in sign. Everything is positive, which means that f of x, our original function, has 0 negative real numbers that are zeros. Let's look at another function. Here we have the function f of x equals 4x cubed minus 3x squared plus 2x minus 1. Again, we want to use Descartes' rule of signs to determine the number of positive and negative real zeros that are possible. So we'll start out by looking at our function, just as is, 4x cubed minus 3x squared plus 2x minus 1. How many variations in sign do we have? Well, we go from positive to negative, that's one change. Negative to positive, there's another. And positive to negative, there's another. So we have 3 variations in sign here. Which means that our function has either 3 or less than that by an even number of positive real zeros. So f of x has either 3 or 3 minus 2 would be 1. 1 minus 2 would be -1. We can't have a negative number of real zeros. So 3 or 1 positive real zeros. To look at how many possible negative real zeros we have, we're going to look at f of negative x. So we'll take all of our x's and replace them with negative x's. Notice when I'm replacing those with negative x's, they go in parentheses. Negative x cubed would be negative x cubed, so we have negative 4x cubed. Negative x squared is really positive x squared, so we have negative 3x squared. 2 times negative x is negative 2x, and then minus 1. So how many variations in sign do we have here? Well, it's negative, and then the next term's negative, no variation. Negative, and the next term's negative, no variation. And then last term's negative as well. So we have 0 variations in sign here. Which means that f of x, our original function, has 0 negative real zeros. So how can Descartes' rule of signs help us? Well, we've already looked at how to come up with the list of possible rational numbers. So if we use Descartes' rule of signs and we see that there aren't going to be any negative real zeros for our function, we could rule out all of the negatives from our list of possible rational zeros.